Hi, welcome to N6.1. This is probably your last lesson in place value for your whole entire life, so hopefully you have a good understanding at the end of this video. Place value, the whole system hasn't changed at all from when you studied it when you were younger. We're just going to extremes now. We're going to read really big numbers and really small numbers. And also we have different ways that we can read them. So when numbers get really big, sometimes we abbreviate them like this and put a decimal in and say it's 1.2 billion. And so I'll show you how to do that. And then we have this standard form, which is just writing it all out. So these two are exactly the same number. They're just written in two different ways. One is kind of a short version. Finding examples of really big numbers, newspapers, magazines, online, how much I'm going to win in the lottery on Friday. It's going to be lots. It's been nice knowing you. I will miss you all. Using a calculator to solve problems that use operations. And there's your 4 basic operations right there: multiplying, dividing, adding, subtracting. So most of the time when you have really big numbers like that, or really small numbers with decimals, you wouldn't use, you wouldn't just do the operation in your head. You would probably use a calculator. We'll let you. Estimating the value, explaining the value of a decimal, relating them to fractions. Did you know decimals and fractions are basically the same thing? They're kind of like cousins. They're exactly the same amount. They just are different ways to write it. Putting large and small numbers on a number line and comparing them, seeing which one is bigger. All right, here is ye old place value chart. So let's pop in some numbers here. Okay, so we know from previous lessons that to read this side of the chart, this all shows numbers that are greater than 1. What the other part shows is numbers that are less than 1, because a decimal shows part of a whole, right? It's not a full thing, it's just part of a thing. So to read the big part of the number, the red part, we think about our families. So here are the nobodies, here are the thousands, and here are the millions. So we always start on the far left side. How many millions do we have? Well, there's just 7. How many thousands do we have? There are 809. And how many nobodies do we have? We have 142. Now you'll see here they called them units. This is also known as ones. Okay, so if this number was just the red side, we would say 7,809,142, and we would be done. However, we have this decimal, so here, ladies and gents, is where we get to say and. And was kind of outlawed for a while in place value because in grade 5 you learned that you couldn't use and anymore. You couldn't say 142 because there was no decimal right there. So we reserve the word and for the decimal. That's its job. So this is the and zone. All right, now reading the decimal part. It's not quite the same. You don't organize it into your families. What you do is you pay attention to who's in the last spot. And his spot is known as the 10,000ths. Okay, so if you were going to write 10,000, that's what it would look like. I'm going to turn it into a fraction. And I've put the 164. We don't really need that 0, right? But I'll put it in there to show that this is this same number over here. So here's how we would read the decimal part of the number. All you do is say this number, 164, and then say the slot that it was last seen in, which is this guy, 10,000ths. So the decimal part of this number is 164 10,000ths. Remember that there's the THS ending. It just rolls off the tongue so great. And all the decimals have that awesome little sound at the end. Tenths, hundredths, thousandths, 10,000ths. Nice. Okay, so here's a good picture of our families. This chart has called them units. So far in our class, we've been calling them the nobodies because they just don't have a last name, right? We wouldn't say there's 142 units. We would just say 142. So this is the nobodies. The next family is the thousands, the millions, the billions, the trillions. And if we were to put our decimal in right here, and then we could go on with our family with the tenths, the 100ths, the 1,000ths, the 10,000ths, the 100,000ths. I'm out of screen, I can't go any smaller. But you could go smaller and smaller and smaller and smaller and smaller. In fact, that's what they've done here. They started with the block of 1,000 cubes, and then they broke it into 10 slices. And in each of those slices, there's 100. So we know that 10 slices times 100 is 1,000. Let's count those zeros. 10 slices times 100. So there's 3 zeros altogether. Did you notice there's 3 zeros here? Now we took one of those slices, one of those guys, and chopped it up into 10 rods. And those 10 rods times 10 slices would give you that block of 100. Again, your zeros all match up. And then they took a rod and they split it up into 10 little cubes. Okay, so what happens if we took one of these little cubes and split it up? Well, that becomes your decimal. So here's that little cube. It's now just blown up. And so you'll see representations like this guy over here where they're using base 10 blocks to show a decimal number. So when you were little in grade 1 and grade 2, we used these blocks to show whole numbers. And this would have been 1,000 and this guy would have been hundreds, and these would have been the tens, and these would have been the ones, right? So now you can also use those to represent decimals. But here's the trick, and you might get caught up on this if you're learning from a textbook or off the internet. Sometimes they use the 100 slabs, the square, as their 1. But sometimes they use the 1,000 block as the 1. And it doesn't really matter which one you use, just know that this isn't always showing 1. Sometimes those 100 squares are showing 1. So usually they tell you, and for example, they've given you kind of a sample problem up here with the orange ones. So we have 1, and then we have another 1, and then we have these rods, and there's 6 of those. So they said there's 2 whole, right? That was these guys. And then we had 0.6, or 6/10. Make sense? Okay, so let's try the next one. We have 1 whole, so that's going to be 1 point something, or 1 decimal something. We have 1, 2, 3, 4 tenths, and then we have 3 hundredths. So 1, and our 43 goes here. Remember the last, remember when we're naming decimals, they get named by this guy's slot, and he was hundredths. So 43 over 100, or 43 hundredths. Love that word. It's just so great. Okay, so let's do a little practice. We know that we are going to name these decimals by their last member. Okay? And so this is the tenths, and this is the hundredth. So this is 89 hundredths, okay, which is this guy here, right? 0.89 is 89 hundredths, or we could write it like a fraction, 89 hundredths. Okay, let's try the next one. We have a decimal, we have a 1, a 3, a 5, and a 4. Okay, who's the last guy? He's the 10 thousandths. If you're not sure how many zeros a 10 thousandths has, you can refer back to your chart and know that there's 1, 2, 3, 4 places. So 4 zeros. 1354 on the top and 10,000 on the bottom. So 1,354 10 thousandths is his name. Okay, let's try the light blue one. We have our decimal, a 1, a 2, a 4, a 3, and a 9, and an 8, and a 7. Okay, so the regular part of the number, the whole part of the number, we arrange into our families. There's your nobodies, and there's our thousands. So we have 1,000. We have 243 nobodies, so just 1,243. And then we get to say and for the decimal, 987 thousandths, because that's this guy's home. He's the last guy in the row. He gets to name the decimal family. Thousand, there we go. Or 1,243, and we're going to make a fraction, 987 thousandths. Okay, 3 decimal places, 3 zeros. Let's try this big green guy. I'm not going to put it into the chart. Let's just draw some loops for our families. When you have a really big number like the green number there, you can't just start reading from this side and hope for the best and hope you have it all organized. So think about your families first. Let's draw some loops. Nobodies, thousands, millions, billions. Okay. Now there's only one member of the family home in the billions, which is fine. 9,361,587. I'm doing so good. I haven't even said and yet in the wrong spot. I should get paid more for these things. 587, where was I? 1,000. 9. Ha. And 9/10. Okay. So a common misconception is that people would say and 9 right there, because 9,361,587,000 and 9 just seems to roll off people's tongue. But remember, reserve your and for the decimal. That guy. Okay, now something else about this number, we have some zeros on the end here. Just ignore them. You can put zeros all day long. Savannah loves to do that. What that means is absolutely nothing. It means that there's nobody home in any of these place values up here. So we're not going to name them, we're not going to name that decimal by these guys that aren't home. We're going to name it by the one that is home. We have a 9 in that spot and our decimal, right? So the name is tenths, 9/10, which is right here. All right, our last example. I've arranged it into the families for you because I'm super nice like that. Okay, 3 families. So we have our nobodies, our thousands, and our millions. And then we have 1, 2, 3, 4, 5 place values. 1, 2, 3, 4, 5. So what place value is here beside the 10 thousandths? Well, think about adding one more 0 to your 10, which would make 100. So that next place value is 100 thousandths. Didn't leave enough room for my THS. Okay, so we have 489,056,300, and again, ignore that 0. We're not going to talk about it. We are going to name our decimal by the last place guy who happens to be in the 100,000 column. So, and 9,086, sorry, 100 thousandths. So this number by itself is just 9,086. 9,086 100 thousandths into the abyss. Okay. Let's put these into decimal form real quick. Or sorry, into fraction form. They already are decimals. So 89, or sorry, 0.89, that 9 is in the hundredths spot. So that means that the bottom of your fraction is going to be the 100. And we have 89 over 100, which coincidentally is also known as 89%, because anything over 100 is percent. Did you know? Okay, let's try this light blue example. Think about your families. This guy is the only 1,000 that we have, so we have 1,243, and now the decimal part. 987, we just say the number and name it by the last digit, which happens to be 3 digits in, so that is thousandths. All right. Good luck with the very, very last place value lesson of your life. Yay!